Now let's look at another example. 3/5 times 7/10. Okay, before we multiply, we want to make sure there are no common factors or common divisors. And I need to be careful here. It's very tempting to use the 5 and the 10, since 5 will go into 10 two times. But you cannot use two denominators. You have to reduce with a numerator and a denominator. So this particular problem is one in which nothing can be reduced. So you just multiply things the way they are. So your answer is going to be 21 over 50. And of course the 21 and the 50 cannot be reduced either. Look at one more example. (3/4) times 8/15 times 25/32. Well, I can reduce with the 3 and the 15. So 3 will go into 3 one time. 3 will go into 15 5 times. 4 will go into 4 one time. And 4 will go into 8 two times. And then I can use some of the numbers that I've already reduced to reduce again. I can use the 2 with the 32 and divide 2 into 2 and get a 1. And 2 will go into 32 16 times. And then I can use this 5 again. 5 will go into 25, so 5 into 5 one time, and 5 into 25 5 times. So sometimes you can reduce a number more than once. That leaves me with 1 over 1 times 1 over 1 times 5 over 16. And when I multiply numerators together, I get 5. When I multiply denominators together, I get 16. Now let's do some multiplication with mixed numbers. Remember, a mixed number is a number and a fraction. So let's multiply 2 3/4 by 3 and 3/5. In order to do that, we need to make the mixed numbers improper fractions. So you remember, to get an improper fraction, we say 4 times 2 is 8, plus the 3 gives us 11 fours. Times, and we say 5 times 3 is 15, plus the 3 gives us 18 fifths. Then, after we get them turned into improper fractions, we're ready to reduce. So if you look at the 4 and the 18, you'll notice that they'll go into each other. Well, they won't go into each other, but they have common factors. 2 will go into both 4 and 18. So we'll mark the 4 and the 18 out, and we'll divide 2 into each of them. 2 will go into 4 2 times, and 2 will go into 18 9 times. And that's the only reducing that we can do. So we'll multiply 11 times 9 and get 99. And we'll multiply 2 times 5 and get 10. And it's fine, since we've divided out all of our common factors, to leave our answer as 99 tenths. Or, if we want to change it back to a mixed number, we can do that by dividing 10 into 99. That goes 9 times, and we have 9 left. So it would be 9 tenths left. So 99 tenths is the same thing as 9 and 9 tenths. You can leave your answer either way you prefer. Just remember, if you change it back to a mixed number, be careful and make sure you don't make a mistake. You might check back and say 10 times 9 is 9 plus the 9 to make sure you would go back and get the 99 tenths. Let's look at another example. This time, let's multiply 6 2/3 by 12. So we're going change the 6 2/3 into an improper fraction. When we do that, 3 times 6 is 18, plus 2 gives us 20/3. And then we want to make the 12 look like a fraction too, so we'll put a 1 under it. You can always make the denominator of a whole number 1 to make it look like a fraction. And then we'll be ready to reduce. We can reduce the 3 and the 12. 3 goes into 3 one time, 3 goes into 12 4 times. So if we multiply across, numerator times numerator, 20 times 4 gives us 80. 1 times 1 gives us 1. So we end up with 80 over 1. And we'd like to go ahead and say 1 will go into 80 times. So our answer is 80. Now I'd like for you to do some practice problems. Number 1, 4/5 times 25 34s. Number 2, 1/2 times 3/4 times 5/6 times 2/5. Number 3, 14 times 7/8. Number 4, 4 3/8 times 5 1/7. Copy the problems down. When you finish copying them down, cut the tape off and work them. Once you have the answers, cut the tape back on and check them. The practice problem answers are number 1, 10/17, number 2, 1/48, number 3, 49/4, or if you'd rather make it a mixed number, 12 1/4, number 4, 45/2, or the mixed number 22½. If you have an answer that disagrees with one of these, stop the tape and get some help. Now let's leave our multiplication for a moment and do some division with fractions. The first problem I want to think about is 4 divided by 1/2. Now I can actually show you a picture of what it means to take 4 and divide it by 1/2. What I've done is I've drawn 4 circles to represent my 4. And I'm going to take those 4 circles and divide each of them in half. So let's do that. So I've taken each of my 4 circles and divided them in half. Now the question is, how many halves are there when I take 4 and divide it in half? Into halves. So if I count, I have 1, 2, 3, 4, 5, 6, 7, 8. So 4 divided into halves gives us 8. So there are 8 halves when we take 4 and divide it by half. The way we do the problem is we make the 4 look like a fraction by putting a 1 under it. And then the way you do division is you change division into multiplying and flip your second fraction or your divisor. We call doing that flipping, finding its reciprocal, and make it 2 over 1. And then we follow our multiplication rules. We multiply numerator by numerator to get the 8, and 1 times 1 is 1. And 8 over 1 does give us 8. So that's the way we do division of fractions. So let's look at how that looks when stated as a rule.